Let's walk through this is the AP Exam Review Worksheet 2. Number 1, it says the function is defined on the interval from -4 to 4, and the graph is shown on the right. Which of the following statements are true? So let's look at these three statements here. Limit as x approaches 1 of the function is equal to -1. That means in order for a limit to exist, the graph has to approach the y value of -1 from both sides, on either side of 1. So let's look at where 1 is. 1 is here. Okay, here's x equals 1. From the left side, we see that the limit is approaching -1. Sorry, approaching -2 rather. And then as we approach 1 from the right side of 1, we're also approaching -2. So even though the order pair is at -1, we see that the graph is leading us to a different y value. And the location that the graph is leading to will be the limit. So limit should be -2 and not -1. So first statement is false. Limit as h approaches 0 of f of 2 plus h minus f of 2 over h equals 2. One thing we need to be able to recognize is that this is actually a notation that represents the derivative of a function at a point. So this is using more of a conceptual understanding of what this notation represents, which is the derivative at a point. So this is basically saying the function, the derivative of the graph at 2 is equal to 2. So in other words, f prime of 2 is equal to 2. We want to know if this is a true statement. So that means at 2, which is this this portion of the graph here, is asking, is this portion of the graph equal to 2? Is that a true or false statement? So we know this is a straight line, so we know that the slope at any point on this for this portion of the graph will be consistent, be the same. So the way we find the slope of a line is we can pick 2 points on the graph and then just do rise over run. So from one point to this point, it's up 2 over 1, so the slope is 2 over 1. The slope is 2, and that's a true statement. Okay, limit as x approaches -1 from the right side of -1 is equal to the y value at -3. So the limit as x approaches -1 from the right side of 1, we see that if we're approaching, -1 from the right side of 1, we see that the y value, the limit is actually going to be +1. Okay, f of -3 is the order pair at this point. So the order pair of the graph at this point is also +1. So limit as x approaches 1 from the right side of 1 is +1. The order pair at f of 3 is also +1. So that's a true statement. Number 2, the integral of absolute value of 4 minus 2x from -1 to 4 is equal to. One thing that we can do is we could split this up into 2 piecewise functions and then just take the integral from -1 to 2 and then from 2 to 4 of 2 separate piecewise functions, because essentially absolute value function is just made up of 2 linear graphs, two straight lines. Another way to think of this is we know that this is going to form a triangle. So 2 triangles, and if we can sketch out those triangles, we can just find the area of those 2 triangles between the graph and the x-axis, and then add the 2 areas together. So we know that 4 minus 2x, what we can do is we can factor out a 2 to make it a little bit simpler here. So the absolute value of 2 minus x has a vertex at whatever will cause it to be 0. So the vertex is at 2. So we know the vertex is at 2, so we can sketch a graph where the vertex is at 2, 0. And then we know the graph is going to go out in a pattern that looks like a V. So we know that the graph will extend to wherever the y value is at -1. So if we plug -1 into the 2 minus x, because we're just graphing the 2 minus x, the 2 will just multiply that at the end. So we're going to ignore this 2 and then just deal with it algebraically. But for the graph, we'll just deal with the -1 to 4 for 2 minus x. So if we plug -1 into this expression, 2 minus -1 is going to be 3, so that will be where the left portion of the graph will end. If we plug 4 into this graph, into the expression, 2 minus 4 is -2. Absolute value of -2 is +2. So we know the graph will end at 4, 2. and essentially we just have to add the two areas of these triangles. This is if we add the area of this triangle. First off, the height of this triangle is going to be 3, and the width is going to be 4. So 1/2 3 times, let's see, 1 2 3, sorry, this is going to be 3 here. So the distance is 3 and this is 3, so 1/2 base times height, it will be 9/2. And then for this triangle here, this will be width of 2 and height of 2, so 1/2 2 times 2 is 4/2, which is 2. So 9/2 plus 2 will be the area of these two triangles, and then you have to multiply by the coefficient that's out in front of the integral here. So 9/2 plus 2 times 2 will give us 13. Number 3, y is equal to 5 plus the definite integral from 2 to 2x e to negative t squared. Which of the following is true? We're asking for the derivative function, and we're also asking for what is y of 1 equal to. So the derivative of this function, so let's take one term at a time. The derivative for 5 will be 0. The constant will go to 0. The derivative for this expression will require us to use second theorem of calculus, which is if we're trying to find the derivative of notation that has a definite integral, essentially the derivative of the definite integral, essentially they cancel out. We should deal with the upper bound. So what we do is we plug the upper bound into the t value, and then we multiply by the upper bound's derivative. So e to the negative 2x quantity squared, which is e to negative 4x squared, times the upper bound's derivative, so times 2. So that's our derivative. Our derivative will be 2e to the negative 4x squared. And then next, if we want to find y of 1, we can just plug 1 into the expression. So if we plug 1 into x, the integral from 2 to 2, we know that if the lower and upper bound matches, we know there's no area that is swept for us to find. So we know that will go to 0, so y is equal to 5. Y of 1 is equal to 5. So answer choice E. Number 4, what are the horizontal asymptotes for the graph? So one thing that we have to be careful about is horizontal asymptotes. Usually we think in terms of just finding the limit as x approaches infinity. So we have to consider that sometimes we may have asymptotes that are different depending on whether we're going to positive or to negative infinity. So we have to consider both. In this case, we're going to have two separate horizontal asymptotes. So that's how this problem is a little bit tricky. So we're going to find the limit as x approaches infinity first. So x approaches infinity. What we can do is, if it's approaching infinity, we can just look at the expression that has the higher degree, and 5 and the 1 is no comparison to this exponential function. So we can just take the coefficients of the exponential function. This is essentially the same. It's just positive and negative. So really it's down to 2 to infinity over negative 2 to infinity, and they will cancel out. The coefficients will just be 1 since they cancel out. So negative 1 because of this negative in front of the 2 to the x in the denominator. Now if we want to find limit as x approaches negative infinity, what we're going to do is we're going to replace each of the x we see with negative infinity. And 2 to negative infinity, we have to be careful about this. Another way to rewrite this is 1 over 2 to infinity. And we know this expression will go to 0 because as 2 goes to infinity, this fraction will go to 0. So 5 plus 0, and same thing here, this will go to 0, 1 minus 0. So 5 over 1 is equal to 5. So we have two horizontal asymptotes, one at negative 1, one at y equals negative 1, and the other at y equals 5.